Inside this episode, reviewing the last 50 years of tropical cyclones to forecast the future. A workshop offering new methods and strategies of warfare, keeping the human in the loop with design thinking. Tropical cyclones with higher wind speeds, a wetter Asian monsoon, and more intense mid-latitude storms. Observing and forecasting tropical cyclones remain in utmost importance. A very distinguished research professor reminds us of the progress made within the past 50 years and how such knowledge can help reduce damage and loss of life.
What everyone really focuses on is the position of the tropical cyclone because of the strong winds in the inner core of the tropical cyclone. Those strong winds drive the waves, and so what the Navy needs to know is what is the highest winds in the storm, but also what is the structure of the storm. But we can have monster typhoons out in the western North Pacific. We can also have smaller than average tropical cyclones, and they can form in a very rapid time frame, and not only can they spin up very fast, but they can also spin down very fast. So out in the western North Pacific, the fleet and the bases around the Pacific are threatened by these typhoons actually almost all year. From the beginning of the season could be as early as February and continue through December into January. So it is a great threat to our fleet, both offshore and onshore. So we need to keep the ships outside of the 35-knot wind radius and outside the 12-foot seas. If you have to bring the ships out of a base, when do you have to get them? Where can they move in order to remain safe? In the old days, if they could forecast it for 36 hours, that was wonderful. Then we went to 72-hour forecasts, and as we learn more, and again, the Office of Naval Research and its various field experiments that they've supported over the years in the Western Pacific, we've made advances in tropical cyclone track forecasting. And again, it's the people at the Naval Research Lab who do the numerical modeling for Fleet Numerical, and Fleet Numerical runs those numerical models and produces the forecast for the fleet throughout the western North Pacific and other parts of the globe. One of the great advances in tropical cyclone, as you can see, this is the satellite image. This is done because of geostationary satellites, which are 22,300 miles away from it, positioned over the equator. They look down and are able to see this whole expanse of ocean. It's whenever we could see every single storm around the world all the time that we made this great advance in being able to observe the intensity from satellites. When we were able to do that, we were then able to supplement that from the few Raywin sounds, which are the balloon soundings which go up and measure the wind, temperature, and humidity. That's all we had in those days. But when the satellite came, with especially the geostationary satellites, with these atmospheric motion vectors, which tell us the winds over the ocean that we didn't know, our models got so much better. But then we've also, and this is especially true at Fleet Numerical with the help of the Naval Research Lab in Monterey, they developed these advanced models which make use of this new observations over the ocean that allow us to make these better forecasts. So better observing technology from the satellites and much faster computers, much better models have made it possible to make these kinds of forecasts much more accurate, much longer in time. We now make 5-day forecasts. And what I am working on now with medium-range weather forecasts is to extend that beyond 5 days. We are now looking at 15-day forecasts twice a day and out to 32 days twice a week, just because of our cooperation with the different field experiments from the Office of Naval Research. So we're supporting now a NASA field experiment called HS3 in the Atlantic, in which we've been looking at storms like that developing in the Atlantic so that they can plan their missions with these global hawks, which fly, they're unmanned aircraft that fly at 60,000 feet and are able to drop sun that's right down through the entire storm. Rather than just seeing the bottom of the storm, they are able to see the whole storm. And those instruments on board the Global Hawks are potential satellite missions or instruments in the future. So we're looking to help even down in the next generation of satellite products as well. So it's been a very exciting experiment this summer. We've participated for 3 years now with this field experiment, which is a cooperation of NASA and NOAA and other agencies, especially the Office of Naval Research, is where we get our funding to participate in these kinds of field experiments. It's what keeps things really interesting for us, interesting for our students, interesting especially for our PhD students and postdocs. We work closely with the operational part of the World Meteorological Organization, the Tropical Cyclone Program. It had to be that all the nations in the world had to cooperate. They had to share their data sets. And that's really another reason. It's not just that the United States could do all this. The United States couldn't do all this. We had to have the satellites which are launched by Japan in cooperation sometimes with the United States. China has now their own satellite program. They have to share this. We have to all work together on this kind of a problem because it affects people all over the globe. We get the observations into the models are better, the outputs are better, we make better forecasts, we provide the forecasters better products, the forecasters are better trained, they make better forecasts. We use social media, we use everything we can to get the message out and educate people on how they should react. When should you move? Where should you go? Again, tropical cyclones, important to the Navy, and the Office of Naval Research has been an important part of my being able to continue this research for over 30 years now.
I'm Associate Professor Ray Buettner. I'm the Director for the Consortium for Robotics and Unmanned Systems Education and Research here at the Naval Postgraduate School. And in that role, we're the co-sponsors for the Warfare Innovation Workshop. What we try to do with the workshop is bring together some of our brightest and most energetic students, mostly naval officers, but we also have Army and Air Force officers participating in the event. We team them up with some of the best engineers from industry and government laboratories and put them in an environment with just a thread of a scenario to stimulate those innovative juices. And we try to get the students to help us think about what concepts should be explored over the next 2 years as part of the Warfare Innovation Continuum that the Navy Warfare Development Command runs through our Chair of Innovation here, Captain Jeff Kline.
This is actually our fourth Warfare Innovation Workshop associated with both the Navy Warfare Development Command and the Consortium for Robotics, Unmanned Systems, and Education and Research. We take those good ideas, we spread them across campus, they become capstone projects, they become thesis work, and they also become research threads for both the Consortium for Robotics, Unmanned Systems, Education and Research, and our Littoral Operations Center. So in a way, we're tying the central theme with our graduate education to make a real impact for the Navy. One of the most interesting challenges that we have when we take a look at the littoral environment is just how complex it is. You have changing weather, you have changing environmental conditions, both the oceanography and the meteorology of a particular environment is unique to the local area in which you're trying to assume naval operations. When that happens, regular tactics, deep water tactics don't necessarily apply. So we're challenging our students and our guests from industry here in order to try to address those challenges head on to see if there's some unique concepts that we might be able to develop from this workshop.
The Marine Corps concept for putting small groups on islands in the middle of the South China Sea so that they can assist naval forces, potentially swarming naval sources, manned and unmanned aircraft, and surface and subsurface vehicles, came out of one of these workshops 2 years ago. The concept for distributing naval forces, breaking apart a carrier air wing potentially, and sending it throughout the area of conflict, those types of ideas have all arisen out of here, as well as concepts such as network optional warfare. We focus a lot on taking advantage of the network. How do we fight if the network goes away? And that concept's been explored, and we're actually funding research projects, developing prototypes, and using these concepts in our courses across the campus.
So you see there's a difference between having great ideas and then actually having them turn into something of tangible value. So when I talk about innovation, I get people to think about the two sides of it. One is the idea process, getting ideas, something new on the table, making it tangible, but then taking that tangible thing and say, how can I create value out of that tangible thing? And almost everything has a value equation attached to it, and I define value as benefits over costs. So you could do that in the private sector pretty easily by looking at economic value. In the military, it's a little different, but you can always put value equation around something. If I can get an MRAP overseas to protect our troops 2 months earlier than I do now, there's a value to that. If I can get an injured soldier to a field hospital 10 minutes sooner than we are now, there's a value to that. So I ask people to think of innovation as, using creative thought processes of the mind that we all have as inherent in us, trying to apply that process to some outcome, better performance, outsmart, outmaneuver the enemy, and that's got to result in some sort of tangible set of capabilities or something new that can be applied and create value. So I ask people to think about innovation as not just the fun part, which is the ideation part. Everybody thinks of innovation as thinking up cool stuff, but it's only cool if you actually can do something with it and it helps somebody.
1, 2, 3. The SSG group, we've come together, 7 of us. We're going off to Newport after we graduate, so we came together here for our first initial experience working together. So we've had quite a bit of fun actually coming up with some of these creative ideas that we are about to present. It's a great experience to learn and try and think outside the box.
We worked together really well. It was fun coming up with like the crazy off-the-wall ideas and then actually figuring out a way to use them and make them useful instead of, completely insane.
Probably no place else on the planet where you can bring together naval expertise, industry, academia, put them together in a context that allows us to explore innovative ideas across the spectrum from technical to legal to ethical in one place and do it as part of an educational program. It's a very efficient use of the taxpayers' resources and a really great way for us to help the Naval Postgraduate School execute its unique mission.
People think in ways that are routine, that are part of standard operating procedures. They are focused on the analytics, and they don't necessarily pause at the very beginning to think about whether they framed the problem well. So trying to understand from the human's perspective what the problems are, what the issues are, what needs improvement, what problems they are encountering that a design challenge could address in a creative, innovative way. That in a nutshell for me is what design thinking is. It's an invitation to think differently, problem solve differently, and certainly an invitation to be much more creative and innovative in that thinking process. Part of design thinking is to help people be visual problem solvers. If you are in a team and somebody's taking notes or the information is going into the computer, you're not sure that everybody is understanding and framing the problem in the same way. They're using the same words, but they may have different meanings and interpretation.
It would be easy to just write things on the board, but using a sticky note helps to organize your own thoughts. You write one thought on one sticky note and put it up on a board. It lets everybody else see it. And it also helps you to organize it, to move it, to think about things a different way. It's just one thought. Don't try and think too much about it. Just keep it really simple.
Sticky notes are also a way to do shorthand. You know, you don't have to worry about pages and pages of text. You can get shorthand statements about feedback, for example. What are the key themes, key issues that people in this interview process found important, and that can get flagged. And it's much easier to work with data than that are laid out in that simplified visual format so that the group can very quickly move on and not get bogged down.
One of the main things I got out of the class was just how to think in a more open-minded way. Usually in my time in the Navy, we have been given a way to think. We have been given specific guidelines, given specific regulations and rules to follow, and these were always kind of considered constraints. Whereas in this class, we kind of took the perspective of forget about all those constraints, forget about everything you've been told. Now let's look at it from a brand new blank sheet of paper, brand new open slate, and let's take it from there. If we were going to design it from that point, what should it look like?
So design thinking spends a great deal of time getting input from users, from customers, from people who are in the problem space.
We encourage feedback as much as possible. No idea is a bad idea unless it's unspoken. So you need to say it, you need to speak up.
Design thinking actually came out of the Stanford engineering department, mechanical engineering actually. It was clear to the engineers at the time that they were very, very good at being very analytical, but they needed some help in being creative and innovative, the front end of the analytics. And so gradually over time, they began to experiment with different ways of teaching their engineers, and eventually others on campus, how to emphasize the human in the loop of the problem-solving process, because they were being forgotten. The customer sometimes did not have a voice, and the focus was more on the analytical aspects of design as opposed to the human aspects of design. So David Kelly, who began with others at the Stanford Design School, started focusing on this approach to problem solving that eventually is now catching on not only in universities throughout the United States, but throughout the world.
One of the big things going on in the Defense Analysis Department is design thinking. We work closely with Stanford University and are inspired very much by the example they've set in various areas of endeavor. We, however, are the first ones to apply this kind of design thinking to the business of military and security affairs. In military affairs, the calculations are not simply about the issues of how much force and how much weaponry to deploy somewhere, but rather a larger question about how to organize an operation, what kind of alliance structure to pursue, what sort of information strategy to approach the American people, the international community, our allies, and even our adversaries, about why we are engaging in the actions we're undertaking. So design thinking really is a very holistic approach to strategy. It's nested in the notion of there being a need to consider many different alternatives rather than to fix on one approach, and to allow over time the best elements of each of these alternatives to come together and create the most effective strategy. The Chief of Naval Operations has become interested in this subject and has talked about setting up a design thinking cell. He's also encouraging improvement overall in strategic thought, and I think this can only help the design thinking initiative. In the Army at Fort Leavenworth, there is a campaign design cell at work, and we are coordinating with them. And since we do a great deal of work in our Defense Analysis Department with the Special Operations community, we're working with the unconventional warriors at Fort Bragg, developing a design thinking initiative. I'm also pleased to note that a number of our allies in the war against terrorism have seen that design alternatives and this kind of thinking can be very productive in their counterterrorism initiatives. And so we're working with a range of our allies as well. When I think about the great enthusiasm for design thinking at the Naval Postgraduate School, the first person I think of is Professor Nancy Roberts, herself a doctorate from Stanford University, and someone who's been involved in design thinking for many years from a management and organization perspective. In our Defense Analysis Department, she's taken a lot of these ideas into the classroom in courses with titles like Wicked Problems, and has really stimulated a high level of interest across the students that attend here at NPS, but also among many of the faculty. She has also been a great ambassador for interest in this subject with the Special Operations Command, with the Chief of Staff of the Army, and indeed in different corridors in the Pentagon as well.
The bottom line for me is that most of faculty that I've talked to, and the students as well, recognize that there has to be a way to get us beyond where we are right now. And it can't be that incremental decision making. It can't be same old, same old. It has to be something that really pushes the edge of that envelope to get us into our future. All signals that I've been getting is, please keep this going forward. Let's do more. Students are extremely interested in having this introduced in some capacity to their coursework. The Naval Postgraduate School could be the center of creative and innovative problem solving for the military.